We all know the feeling of looking at a screen and feeling completely lost. Maybe it's a confusing checkout page or a check engine light that doesn't actually tell you what's wrong. Usually these moments are just frustrating. But on July 3rd, 1988, a confusing screen wasn't just a nuisance. It was a death sentence. Imagine you're sitting in a dark room surrounded by sirens. You have less than 4 minutes to make a decision that will affect the lives of hundreds of people. You look at your monitor for help, but instead of a clear picture, you see a wall of glowing numbers. The computer is trying to tell you something critical, but it's speaking a language of pure abstraction. It's showing you TN4131. It isn't telling you if it's a fighter jet coming to attack you, or a commercial plane filled with families. This is the story of the USS Vincennes. A story about how the world's most advanced warship was defeated not by an enemy, but by its own user interface. Because when a computer makes a simple task impossible to understand, the results aren't just bugs, they are tragedies.
The system didn't crash, it didn't glitch, it performed exactly as programmed. But because of one design choice, 290 people are about to be erased from the sky. This is what a fatal interface looks like.
To understand the tragedy, we have to understand the Aegis combat system. In the 1990s, this was the god mode of naval warfare. It used a massive radar to see every object in the sky for hundreds of miles. The CIC, Combat Information Center, was the brain. Inside, operators sat in front of consoles displaying chaotic amounts of data. But Aegis didn't show planes, it showed tracks. Every object the radar picked up was assigned a track number. For example, TN4131. The interface was designed for a high-density battle against the Soviet Union. It prioritized speed over clarity. It assumed the operators were hyper-trained robots who could memorize hundreds of 4-digit numbers in real time. But humans aren't robots. When we are stressed, our brains stop seeing data and start looking for stories. And the Aegis UI was about to tell the crew of the Vincennes a very dangerous story. Iran Air 655 took off from Bandar Abbas, bound for Dubai. It was a routine commercial flight, flying in a designated civilian corridor. It was climbing steadily. On the Vincennes, the radar picked it up. The system assigned it a tracking number, TN4131. At the same time, the Vincennes was in a surface battle with Iranian gunboats. The ship was vibrating from its own guns. The adrenaline in the room was at breaking point. One operator looked at his screen. He saw TN4131. Then, something catastrophic happened in the software. The Aegis system recycled track numbers. A previous track, an Iranian fighter jet from earlier in the day, was also assigned a similar track number. Because of how the UI displayed the list, the operator's brain performed a mapping error. He thought the civilian Airbus was descending, a classic attack profile. In a modern UI, we use trend lines. If a plane is going down, the line points down. But in 1988, Aegis only showed the raw number. The operator had to look at that number, say 12,000 feet, wait 5 seconds, look again, say 11,500 feet, and do the subtraction in his head while sirens were screaming. He called out, "Track 4131 is descending." But he was wrong. It was climbing. But once that story was told, the rest of the crew began to see it too. This is what psychologists call scenario fulfillment. The crew expected an attack, and the UI gave them just enough ambiguous data to support that belief. The commanding officer asked for a confirmation. Is it an F-14? The UI didn't say unknown. It showed the identification code as assumed enemy. Why? Because it was a military jet? No, because it was flying from a military airport. The system guessed, and the humans treated that guess as a fact. At 10:24 AM, the Vincennes fired. The missiles traveled for 30 seconds. The Airbus didn't even have a radar warning system. They never saw it coming. When the report finally came back that the debris was civilian clothing and life jackets, the CIC went silent. The most advanced UI in the world had just facilitated a mass execution because it couldn't distinguish between a 150-foot-long airliner and a 60-foot-long fighter jet. The investigation didn't blame the software. They blamed stress. But stress is an environmental variable. If the Aegis screen had used a simple icon, a large square for a civilian plane and a small triangle for a fighter, those 290 people would still be alive. If the screen had shown a trend arrow pointing up for climbing, the operator would have seen his error instantly. The tragedy of Flight 655 changed the way that we design interfaces for high-stakes environments. From nuclear power plants to hospital ICUs, we learned that the user isn't just a person, it's a person under pressure. But in 2026, we still make these mistakes. We prioritize density over clarity. We build systems that are powerful, yet unreadable. And as the Hawaii missile alert or the Citigroup disaster show us, the cost of bad UI is never just a bug. It's a tragedy, waiting for a click.